Hey everybody. So, today's lesson is going to be kind of short. We're just going to do another dual simplex example. I was considering starting something new, but we're going to do a test on Friday. So I thought it'd be better not to crowd your head with too many other ideas, because we're going to start something interesting after our test, so next week. So I just wanted to do another dual simplex example, maybe where I copy everything correctly this time. If you watched the last video, you'll know that I copied, when I went to copy from the example to the first table, that I kind of messed that up. But it still worked out. It was alright, right? So let's see. I will need two slack variables. So we're going to try to do the dual simplex again. And right hand side. And I would say help me copy it over, but you're not really here with me, which is sad. Okay, so if I go to copy this over, let's see, I'll have 2, 1, and since it's greater than or equal to, I will have a negative slack. Okay, down here I have 1, 2, oh, it's lagging, hang on a second. Come on, thing. Negative slack because it's greater than or equal to. We're subtracting the slack off. Alright, awesome. And then we're going to turn it to a maximization of negative, negative. So we put the opposites 1, 1, 0, 0, 0. Okay, so notice right now I don't have any identity columns because these have a negative sign. I need to make sure I have some identity columns so that I can call these things something. So I know which variable is equal to 10 and which variable is equal to 8. But because this has a negative 1, this is not it. So we say, we'll just multiply through by negative 1, and that will fix it for us. And so we do that. And when we do that, we have a new problem. So let's see. Negative 2, negative 1, 1, 0, negative 10, and we're like, we'll call this slack 1 now. Slack 1. Let's see. Negative 1, negative 2, 0, 1, negative 8. And we'll call this one slack 2 now. And the costs have not changed. Alright, so let's write where we are at. I have an objective function value of 0. And the point we're at, the x's are non-basic, and the slacks are taking value negative 10 and negative 8. But wait a second. That's not feasible, right? That's infeasible. Not allowed to have things with negative. Now, normally we would say, okay, well, let's do a two-phase or a big M. But the reason for having this dual simplex is pretty interesting. This is when we're using the dual simplex. When we look across the top and nothing is attractive, nothing's negative, and we look here and things are infeasible. Just to refresh your memory, if I were to write the dual, it'd be like flipping this thing sideways, and these would be the right-hand sides. And you look at it and you say, all of these right-hand sides are feasible right now. So we would be feasible in the dual, and these would be cost, they would be attractive. So what if we were to just write the dual? Well, let's not write the dual. Let's save the time on not writing the dual, and let's actually just make it feasible, or pivot in the dual, basically. Okay, so we say which one's the most attractive, or the most negative, most out of feasibility. It'd be this one at negative 10, right? And then remember our ratio test. Now we're only going to pivot on negative, so we look down here, we only have these two to compare. Okay, and so the ratio test is the cost divided by the entry. So, and we ignore sign. 1 divided by 2 is a half. 1 divided by 1 is 1. And you take the smaller ratio. So a half is smaller than 1. So we're going to pivot on that guy. So let's see. So who's going to leave the basis is slack 1. Who's going to enter? x1. Alright. So let's do our pivot, hopefully without any mistakes. x1, x2, slack 1, slack 2, right hand side. Okay, let's see. So I'm going to need to multiply through by negative 1/2 to get this to be a 1. So that'll be 1. That'll be a half. That'll be negative a half. Still 0. Positive 5. And this is now going to be x1 entering. x1. Awesome. Alright, so we're going to have to zero out below and the cost. So zeroing out this entire rest of the column, I'm going to need to, I could use these values because I'm going to do the same thing and multiply by negative a half and add down. So negative a half, so that'd be 1 times negative 1 is 0. A half to negative 2/3 is negative 3/2. Negative a half down to 0 is just negative a half. 0 down to 1 is just still 1. Let's see, so 5 added to negative 8 is negative 3. So that one is still slack 2. Also, it's still infeasible, so we still have a little bit more work to do. Now let's zero out this cost here. So here we would just need to multiply by half and add. Multiply by half would leave us with negative 1. Give us 0. Let's see. Multiplying by a half here would give us negative a half plus 1, so positive a half. A half. 0 to 0 does not change. And multiplying by a half would give us negative 5, and we add that up so we get negative 5. But remember, we're doing a minimization problem. So let's see where we are. So that z is opposite signed. We're at 5 right now. Let's see what x value we're at. x1 is now taking value 5. x2 is non-basic, so 0. Slack 1 is non-basic. And slack 2, it has value negative 3. So we're still infeasible. So we're going to do a dual simplex pivot. And this is the only one that's attractive right here. Okay. So we need to do our ratio test. So we look across only on the negatives, and here they are. And we gotta do a ratio test of the cost divided by the entry. So this one's 1. It's the easiest one, ignoring signs. This one is a third, if you were to go a half divided by negative, or 3/2. So that's actually the one that is smaller. And so that's going to win the ratio test. That's where we're going to pivot. So S2 will leave the basis. X2 will enter. Alright. So hopefully this will be our last pivot. Let me write all that down. Okay, let's see here. So I'm going to need to multiply through by negative 2/3. Well, that's going to still be 0. That'll become positive 1. Negative, what did I say? 2/3. So that'll become positive, and it'll give us 1/3. Negative 2/3. I can do that one. Negative 2/3. Negative 2/3 will give us a 2 there. And this is now, what did I say? X2 enters the basis. Alright. So now we're going to want to zero out this entry above. So, we can use these numbers, or we can use these. It does not really matter, but to zero that out, I would need to multiply this. Multiply this by a third, so the 3's would cancel, and then add it up. So a third plus times 0 plus 1 is still 1. A third would make that negative a half, add it up to 0. A third, let's see, that would make that 1/6. We add it up to 1/2, and we would get 2/3. A third, add up to zeros, a third. A third, let's see, would make that 1, and add it to 5, negative 1, add it to 5 would be 4. Alright, awesome. So that's our x1 row. And now for the cost. Oh, is it the same? Half and a half, yeah, so just times a third and do that again. So this one's still 0, this one should be 0. Go in more quickly. This one will be a third, this one will be a third, this one will be -6. Awesome. So let's see where we are now. So z is at 6, and the x value that we're at, the point we're at, x1's at 4, x2 is at 2, and both of the slacks are non-basic at 0. So the first thing you should notice is, yes, we are finally feasible. Yay. There's no attractive cost, so we're optimal. So we're feasible and optimal. We've finished this one. Now I do want to point out some things, some really interesting things that I did not mention last time. I guess not many things. I just want to talk about something. Look at the objective function value. At each pivot, it's going up. Is that weird? Not if we're doing a maximization problem, that's not weird. But if we're doing a minimization problem, that is actually awkward, because usually what we're doing is, if we're minimizing, we're hitting pivots and we're working our way down. And this is always non-increasing, or always decreasing, or at least equal at each pivot, usually just going down. Look at all the minimization problems we've done. Or if it were a maximization problem, we'd expect it to increase at each pivot. But this is moving the opposite direction. Can you think why? Well, the reason is because we're not in the feasibility region. So if I were to draw you a horribly sketchy graph, say that our feasibility region looks something like this. Okay. It doesn't really matter. And usually we would be minimizing down by pivoting down to that minimum point, and each cost would get less. But we're not even in the feasibility region. We could even have an open feasibility region where it's unbounded out in this direction and float down to that answer. We're not in the feasibility region. We started infeasible, so we're down here somewhere. And so what we're going to do is pivot at intersection points until we make it up to feasibility. But as soon as we hit feasibility, we're optimal. We didn't actually have to do any simplex pivots. So we're not even in the feasibility region. We're outside of it. So that's why, if you go back and look, that's why these things are not moving down towards a minimum. They're actually increasing, but they're increasing up until we hit feasibility. So just something I didn't know if anybody had noticed how strange that was. But so anyways, that's all I got for you today. Remember, we're going to test Friday. So remember, I'm going to email you the test, and I'll post it in Blackboard. So Friday morning, I'll email you the test, okay? Friday morning, you're going to get that test. It is due before class starts on Monday. Okay? I would strongly suggest you go ahead and just do it on Friday. It's not going to be any different than our normal test hour. You could probably sit down and do it. If you take your time, since it is open notes and open book, you can look everything up and be sure that you're perfectly, amazing on every pivot and every concept. So if you took extra long, it might only take you 2 hours. I would suggest you do it on Friday. Then I want a PDF scan, or you could type it, of your solutions sent to Blackboard. what I'll do is I'll create the assignment in Blackboard that just lets you upload it for me to be able to grade it. And as a PDF, I'll download it and mark on it and be able to send it back to you. It may take me a little longer to grade in that way, but just bear with me. We're bearing with each other a whole lot with all this online learning stuff. So I'll get it back to you as soon as I can grade it. Maybe not as fast as I usually do. All right. If you have any questions, please email me. And good luck. So there won't be a video Friday, just a test. I want you to do the test. Awesome. Y'all have a good day.